binary events. Binary meaning two outcomes. Okay, just a reminder. And we'll basically call them as success and failure, or S and not S. Of course, we don't technically say S. We might utilize the notations in what they are. Now, we're talking about two different instances of two different things that are independent, or that may or may not be independent of each other. So the idea here is typically you have some event A with the outcomes being A or not A, and then we have another event B in which the outcomes could be B or not B. So you can say yes to or no to each of these two questions. Now, this may be also same event as A. So you can actually do something twice, like flipping a coin. Okay, so we could flip a coin twice, and we can have the first coin toss and then the second coin toss. That's what the variable would be, but the outcomes could be A and not A for both of them. The premise and idea here is that when we talk about the outcomes, we have A and not A, and we have the probability of A, and therefore the probability of getting not A. And when we think about this as for a tree diagram, which we'll get into more next week, but I want to kind of show you the base properties. I don't expect you to do tonight's homework this way, but the purpose is more long term for us. If I add these two, I always get 1. Okay. If I add those two, I get 1. And then we have our next event, which would be B and not B. And that would have the probability of B, and that would probability of not B. And this could also get B and not B. And this has probability of B and the probability of not B. And the same thing is true. This plus this equals 1. This plus this equals 1. All right. So we have those pieces right there. And as a result, we get the different outcomes that we can have. So we can have outcome A, then B, A, not B, not A, B, and not A, not B. And we can find these probabilities by multiplying the two. Probability of A times the probability of B, probability of A times the probability of not B, probability not A times the probability of B, probability of not A times the probability of not B. It should be noted that if I add all 4 of these probabilities, I also get 1 from the end of multiplying all of them. So we can see this, and it helps us because if I just take this probability and this probability and I multiply it, I get this probability over here. So that's a visualization of what's going on. But this same information can actually be utilized as a two-way table. Oh, I did want to talk about one of the questions. So one of the questions last night, and I hope you really took a chance to look at that question. It was the final question from the homework. I think it was the most trickiest one that you might most likely had gotten wrong. Most likely, not got it wrong. It was a very important question, problem 10 on that last one. We want to make sure that we don't double count anything. So when I say, hey, when we talk about the ors, so we would have to make sure that we cover any instances. So for example, if I want to say what is the probability that we get an A or we get a positive A or a positive B outcome, this one has a positive A, this one has a positive A, and well, this one had a positive A and B, has a positive A, this one has a positive B. So it would be these three would be the answer that has the probability of A or B. All right, because it just does. This is the only instance that doesn't. So in these cases, you would just add them together. So the probability of A or B would be these three right here. I'll make a little bit more of a connection when we do our two-way table, because when I do my two-way table, I have outcome A or outcome not A. I have outcome B and outcome not B. And when we fill in these probabilities, this is the probability of A times the probability of B, probability of A times the probability of not B, probability of not A times the probability of B, probability of not A times the probability of not B. We know that if we add all four of these values together, if I take this plus this plus this plus this, they must add up to 1. All right. More importantly, we've also talked about the totals. And this, when we add these two together, this gives me actually the probability of A. All right, because when I add them to the side, that gives me the probability of A. This gives me the probability of not B. This is the probability of B. This is the probability of not B, which we just add the rows or add the columns. And of course, the bottom right-hand corner is should always add up to 1. As a reminder, this plus this equals this, this plus this equals this, plus here equals here, plus equals there. So they should all add up in terms of the rows and columns. Now, in some problems today, it's going to be like a little math puzzle. The more traditional problem, the first example I'm going to give you this information right in here, or I'm going to give you the probability of A and the probability of B, and then you would just multiply the two to get here, and so forth. So we can just do the multiplications to find these 4 boxes. In some instances, I might only give you this probability, I might give you this probability, and I might give you like this probability. And based on giving you these 3 pieces of information, you can do like a puzzle and figure out what this number is, because those two have to add up to get to the A, and then you can figure out what these 2 numbers are, because they have to add up to the bottom one. And then you can figure out these 2 because they need to add up to 1. Same thing with finding this one and this one. So if I give you the correct 3 pieces of information, you can find the other information. In some cases even, I might tell you the probability of A or B. So if I tell you the probability of A or B, the probability that you get A or B, that would be these 3 right here. And this right here would be the probability of neither. So I want to note some extra pieces of information here. The probability of A or B, which is the probability of A union B, is equal to the probability of A times the probability of B. plus the probability of A times the probability of not B plus the probability of not A times the probability of B. So it's those three boxes. And the probability of neither is the same thing as the probability of not A and not B, which is the probability of not A times the probability of not B, which is just that one box. You will need to utilize this information because, like I said, it's going to become a fill in the box. We know this box is always 1. So we have one of the 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 values that have to go into here. All the values have to be less than 1, less than or equal to 1. We know one of those 9 values is 1 right here. And then I will give you enough pieces of information to fill out maybe 2 or 3 others. And with those 2 or 3 others, or with the information, you'll be able to fill in all the other boxes. And then when answering the questions, it becomes just like yesterday. Questions? Okay. Yep. Yeah, exactly. We'll go to the example. All right. So in this example, I'm going to tell you that 30% of students are juniors. 28% of students are juniors who study. 40% of students study. So our goal that we want to do is to find, and we're gonna, you know, I don't ask you this question, but you need to do this for all your homework questions tonight, okay? So we're going to create a two-way table for outcomes. Okay. I don't, and in your homework, like I said, these are not asked. It doesn't tell you to make a two-way table. Some of them, and I'm not too certain, it might ask you to make a Venn diagram. I'm going to, depending on the time we have, I might show you the Venn diagram today. My preference is to make a two-way table, and then the two-way table goes to a Venn diagram. I'm going to do that as a separate part of the lesson at the end. Okay. So we want to create a table for the outcomes. So what I'm going to do here is I'm going to make my table, and I have that the students are either a junior or not a junior, and they either study or they don't study. I also have the totals and I know this box is 1. So now what we're going to do is we're going to take the information that we find here, and each of these ones here, and this isn't always the case, but the 3 pieces of information here are 3 of the values that go inside those 8 boxes that are missing. So the first one is 30% of students are juniors. Where does that go?
The first box?
No. 30% of students are juniors. Notice it only has one word. It only has one of the variables. So this is definitely a marginal.
Oh yeah, sorry, under total, but the first row. Yeah, bro.
There we go, 0.3. Next one. 28% of students are juniors who study.
That's the first one.
And finally, 40% of students study.
The marginal total on the first column.
Perfect. All right, I'm going to pause real quick right here. Now this becomes a math problem, okay? You know the properties of these boxes by now. And from your work on yesterday, in our brief, also going here. So I'm going to pause really quickly. I'm going to give about a minute. I want you to fill in the other boxes because the rest of them is just some basic math. All righty, so we're going to do the rest of the math work in here. I'll use light blue. Yeah, light blue looks good. All right, so the box to the top row box that is missing has to be, and I'm just going to go through them. I'll just go through them. 0.02 because 0.28 plus 0.02 is equal to 0.3, or you could have subtracted them. For the same reason, it just becomes of all of this plus this has to add up to this. So it's a bunch of subtractions really. 0.4 minus 0.28 gives me 0.12 because they have to add up to 0.4. 0.4, 1 minus 0.4 is 0.6. 1 minus 0.3 is 0.7. And it doesn't matter how you do the math, left or right or left, up or down, I mean. The last one gives me 0.58. Questions on how I filled out those boxes? Once you've done that, we're now at the same questions from last night's homework. All right, so now you just have last night's homework. So that's basically the new thing right there. So question B, what is the probability? And I'm going to go for that tough one. I'll do this. A randomly selected student is a junior who doesn't study. Okay, well that's going to be a junior. So this is the probability of a junior and doesn't study. And so that's just one of the boxes. That's nice. And so these 4 boxes represent the probability of an and. Okay, that's what each of those individual boxes is. It's a probability of an and. So probability of a junior and doesn't study, junior and doesn't study is 0.02. I could have also said what's the probability that they are neither a junior nor do they study. C, what is the probability that a randomly selected student is either a junior or studies? Now this is the one from last night that I was saying. So they can be a junior or they can study. So I want to find the probability of a junior or that they study. Now, some people this is going to arise a new formula for us. But if we use the two-way tables, we get the answer right here. So this is going to be the probability of a junior and study plus the probability of a junior and doesn't study, plus the probability of a not a junior and studies. So it's 3 probabilities. It's going to be 0.28 plus 0.02 plus 0.12, which gives me 0.42. This problem actually gives me my new, when doing these problems, I want to note that we do have a new formula. The probability of A or B, okay, is equal to the probability of A plus the probability of B, which in this case would have been me adding the two marginal totals, which would have been 0.3 plus 0.7, or 0.3 plus 0.4. Many students believe that that is going to be the answer. But what we have to do is we have to note that it is possible that we might, it is possible, well, we call it double counting. You are double counting the probability of A and B. So we have to subtract, yes, the probability of A and B. This is the true formula of how to add two probabilities. Now, in 2 days ago, when I showed you the formula for addition, the OR, I want you to note that this comes because we have non-disjoint right here. In the problems that I had given you in the first iteration of these, the probability of A and B was just 0. So if I wanted to find the probability of A and the probability plus or the probability of B, when I was talking about selecting M&Ms, and I said, what's the probability of selecting a red M&M or a blue M&M? Well, we couldn't select a red and a blue M&M, so we didn't have to do any of those subtraction pieces. So we got to be careful that we don't put like 0.7 on this answer, because what that's done is that double counts juniors and studiers. So there's 2 ways to go about doing this problem. You can use this formula, this new formula. I add the 0.3 and 0.7, and then I subtract the 0.28. Or I realize that those 3 boxes right there, those 3 outcomes, and I just add those 3 outcomes together, and I get it. Now, we will be utilizing this formula a little bit more next week. Okay, so that is the true, this is the true addition formula. It's a big one for us. And don't worry, it's on your formula sheet. That one is there, so you don't have to memorize it. It is, I mean, it's given to you on the exam. I mean, I don't know if, like it said, it might be open notes. I don't know. So that's how we do that. And so in terms of the chats, I think I answered those questions. And then part D, what is the probability that a randomly selected junior studies? Okay, now this is where that probability, that the notation is helpful. So I'm asking you, what is the probability that the student did what? What do we want to know? We want to know if they did what? If they studied. So it's the probability of studying given I know that they are already a junior. So this is the probability of studied and a junior over the probability of a junior. And as some of you can have already realized, This is 0.28, which is the probability of a junior and studied. I know they're a junior, and this comes from yesterday's work. I know they are a junior, so all we care of is this row right here. I know they're a junior, so my denominator is 0.3, and I'm asking about if they studied. So 0.28 divided by 0.3. And this is kind of like the same problem that we had gotten yesterday in yesterday's notes, 0.93. So I just wanted to kind of give it to you from a different perspective, but noting that it is the same question. Now, Venn diagrams. So more importantly, I like to talk about doing a Venn diagram. I'll just write Venn. A Venn to a table, or a table to a Venn. Okay, that's the goal. I like to go through everything through the table. Probabilities are much easier when you do them in table format as a two-way table. So sometimes problems are given to you as a Venn diagram. Sometimes the problem will request specifically to draw a Venn diagram. I always like to go through tables. So I will try to make a table first and then make a Venn diagram if I'm requested to make a Venn diagram. If I'm given a Venn diagram, then I want to convert that into a table. That's the way I feel my students are able to best solve the problem. So really we're going to focus on these types of probabilities and these steps, and we get mastery at this. And so if we can make it into looking like that, then we're good. So in a Venn diagram, and you've done Venn diagrams before, the idea here is we have two circles. We have circle A, and so that is all of the outcomes for A, and this is all the outcomes for B. Now, in reality, there are four different sections. There's section 1, section 2, section 3, and section 4. And there are four sections just like our four sections that we had in before. More specifically, this section on the this section right in here is we call the intersection. That is the probability of A and B. This section over here, so that's that right there in purple. We have this other section over here. This green, I call it like a crescent. That's the probability of A and not B. We have this section over here, this other crescent piece. That section is the probability of B and not A. And then we have this outside section over here, everything on the outside. That's the probability of not A and not B. Those four sections represent the four sections of the two-way table. Now, if I were to add, I want to note, and this is where a lot of students go wrong, the probability of A is actually equal to section 1 plus section 3. So you have it's the entire circle. The same thing goes with B. This is probability of 2 plus the section of 3, which is the entire circle. So if I ask you what's the probability of B, a lot of people think that it's just the value that goes right in there. But in reality, and when I say in there, I'm referring to in here. This entire circle would be the probability of B. The mistake most people get is they think, well, probability of B, then that's going to be that little section right here. That's this section right in here, that crescent. And that's where they go wrong. So, question E, as a follow-up to the previous problem, create a Venn diagram. And this is of the juniors in study. So my Venn diagram would be two circles that intersect. I have a circle for my juniors and I have a circle for my studiers. And I'm just going to take the values of them. What number goes inside the intersecting piece? The juniors and studies. From the table that I had above that I created. So I'm asking you to look back to this one right here. It's these four numbers.
28.
Yeah. Those four numbers are all that we get filled in. So it's 0.28. What about the junior, the one to the left? The crescent to the left, those are juniors and doesn't study, because they're not in the study circle.
0.02.
0.02, yes, 0.02. Not a junior because they're outside the junior circle, but they are inside the studying circle. Would be 0.112. And finally, not studies, not a junior. They are not in either circle. They are not in the junior circle. They are not in the study circle. 0.58. So if you're asked specifically to create a Venn diagram, you can just take the information that you have right here, and those four numbers that you get on your table are the four numbers that get written in your Venn diagram. Or similarly, if you are given the Venn diagram like this, then you can rewrite it as these four numbers right here, and then you can do the totals and find all the answers much more easier than the methods that if you just try to only look at the Venn diagram. It's possible. I have actually in my first parts of teaching, I would say, we're going to do this entire problem as a Venn. These are typically considered Venn diagram problems. And we would just do it like this. And then I would say, hey, what's the probability of studying? And people would look at this and they go, oh, 0.12. And I'm like, no, it's 0.12 plus 0.28. So it's 0.4. But we have a harder time seeing it in this Venn diagram than if you just made it into a table and do it that way. The same thing, if I said, hey, what's the probability that you're a junior, that given that you're a junior that you studied? All right, so I know they're a junior, so I'm going to divide by 0.3 because I have to add these two together, but they're junior and studied, so it's 0.8, 0.28. It's a lot harder to just be able to get it rather than the way we did the two-way table. All right, so if you're given a Venn diagram, which I don't think I gave you any problem that just gives you the Venn diagram. I don't believe I did. Most all the problems are something like the information problems that I gave you in the above example. But if I give you a Venn diagram, we turn it into a table, and then the probability questions just flow. All right. The toughest one, and I didn't do an example in here, but you should be able to do it. The toughest one is that if I give you the or. If I give you the or, all right, I want you to note this. If I told you the probability that a student, the trick here is that you're actually, this is the box that you should fill in if you're given the or. So if I told you something like the probability that a student is a junior or studies is 0.42, we know that these three boxes have to add up to 0.42. More specifically, we know this other box has to be the rest. So if I told you the probability that a junior or study is 0.42, then you now know that this box is 0.58. So it's like a trickier way of telling you one of the boxes, because I told you what the other three boxes were. You now know what that remaining box has to be. It is a 3-day weekend. Remember, no school on Monday, so I will see you back on Tuesday. That's all I have for you. Your homework is posted in Google Classroom. Have a great weekend. Enjoy the time for that extra day. Bye.
Have a good weekend.
Have a good weekend.